if I said F composed with G, that's the same thing as saying F of G of X. So remember, we start on the inside and work our way out. So G is X minus 3. And we are plugging that into F. So F is whatever we put in squared. So it would be an X minus 3 squared. So then we would FOIL that, and we would get X squared minus 6X plus 9. Does order matter with compositions? Yes. The other way, G composed with F, means you are going to start with function F. So we start on the inside. F is X squared. And we're plugging that into G. So it becomes X squared minus 3. So most of the time when we did compositions, we were looking at equations like this, but we could also do a composition from a graph or a T-chart, something like that. So I wanted to look at a couple other examples with those. Are we okay on this one? So let's look at this. A lot of different ones, and I tried to write them a couple different ways. So A, F of G of 1. So you start on the inside. This says when X is 1, tell me what function G is equal to. So when X is 1, G is 6. So G of 1 gets replaced with a 6. So now I have to find F of 6. That means when X is 6, what is function F equal to? 5. B. G of F of 1. So starting on the inside, when X is 1, we're putting that into F. So when X is 1, function F is 3. Okay, when X is 3, function G is 2. C. F of 1. We can do it with the same function. So F of 1, when X is 1, function F is 3. And F of 3, when X is 3, function F is 4. Why don't you guys try the next couple? So G of 1. So G of 1 is 6. G of 6 is 3. E. G composed with F of 3. So we start with F of 3. When X is 3, function F is 4. So G of 4. When X is 4, function G is 1. F. F composed decomposed with g of 6. So we start with g of 6. When x is 6, g is 3. And we have f of 3. So when x is 3, f is 4. How do we do with those? Okay.
Would we play that in the lab?
No, as long as you get
Wait,
it.
why wouldn't you play with that?
If we,
Okay.
A baseball fan?
if we lose the first game and then win, we're playing social. But if we win the first game and then we're playing social.
Alright, next step. I want you guys to find a partner. If you look on Google Classroom, I posted a handout that's doing this same thing except with a graph. So remember we have read, on our last quiz, I asked you like g of 2 and you had to go when x was 2, what's the value of g on the graph? So you're doing that same thing, practicing these compositions from those graphs. Where we are just doing compositions from the equation. Alright, so this one, g of f of x. So we start on the inside. F is 3x minus 1. I am plugging that into g. That means in g, every time I see an x, I am replacing it with 3x minus 1. Alright, so what do we have to do here? 12. So that will be 9x squared minus 6x plus 1. Are you guys okay if I don't show my work for what's the next step? Positive 12x and negative 12x cancel. Negative 2 plus 4 plus 5. 7. B. So start on the inside. G of x is the square root of x plus 6. We're putting that into f, so that means in function f, every time we see an x, we replace it with the square root of x plus 6. So what happens? We get x plus 10. Why don't you guys try the next two? Just do the compositions. We'll talk about the domains in a minute. So the first one, we're beginning on the f of x, which is the square root of x. I'm putting that into f, which means in f I replace my x with the square root of x. So that gives me the square root of the square root of x. Does anyone know another way you could write that? This is a square root and a square root. 2 times 2 is 4, so you could also say a fourth root of x. Either way is fine. They are equivalent.
This is never put up.
Why? It wasn't hard, it just looks ugly.
Make it please.
It's just one of those that it's really good to shake your confidence. You look at it and think you did something wrong, but you didn't. Okay, the other thing I asked, and I said not to do it on your own, domain. When we did the domains of compositions in college algebra, we had to look at 2 things. Okay, we have to look at the final answer, but we also had to look at the first function. Everybody with me here? Okay, because what happens is I am going to take a number first and plug it into the square root of x, right? And then it spits out an answer, and then that answer has to work at the end. So when we did these domains, we had to look 2 places and put them together. We have to check the inside and the final answer. Now in this case, they're pretty similar. This one, we had a square root of x. What do we know about square roots? So we know right now x is greater than or equal to 0. Final answer, it's a fourth root. What do we know about that? Same thing. So my domain would just be 0 to infinity. Let's look at the next one. This means g of f of x. So start on the inside, f of x is the square root of x. I am plugging that into g. So g is the square root of 2 minus the square root of x. So that's my composition. Okay, domain. 2 places. Right here. What do we know? Okay, right here, this is all under the radical, so that tells me 2 minus the square root of x has to be greater than or equal to 0, right? Okay, what would you do? If I divide by a negative, what happens? Okay, then what? You had a square root. So it's square. So I get x has to be less than or equal to 4. So I have to put these together. It has to be greater than or equal to 0, less than or equal to 4. So what answers can I put in? Greater than or equal to 0 would be this. Less than or equal to 4 would be this. So the only thing that works for both of them are the numbers in between 0. Okay, let's think about that. If I try putting in a negative 4 to start with, can you plug a negative 4 into f? No, so we can't do the negatives to begin with. What if I started by putting in a 9? I can do the square root of 9, can't I? And I get 3. Can I plug a 3 into this one? No. So that's why we had to look both at the inside and the final piece. So only answers between 0 and 4 would work for everything. Alright, we are going to cover the next 2 slides. They're the same topic, and that's going to be our stopping point for today. So I want to work, this one is just another composition. So it's just a 3 function, and we are working with their equations. So f composed with g composed with h. That means f of g of h. Okay, you start on the inside. What is h of x? work the g of x plus 3. So that says you go to function g, we replace the x with x plus 3. Finally, I plug that into f. So I am replacing each of these x's with an x plus 3 to the 10. X plus 3 to the 10 over x plus 3 to the 10 plus 1. Okay, so we can do as many compositions as we want. We just keep working one, get that answer, put it into the next. Final thing, I want to try going backwards. So if I tell you the composition, can we figure out what the original functions were? Or a possibility, because sometimes there's multiple options. I want function f, capital F, to equal f composed with g. So what that means, if I did f of g of x, I got this for my answer. So you need to tell me what f of x and g of x were to start with. When we did this last year, and we said, okay, look at the center. The inside is g of x. So the inside, that's like the first thing you would do. If you're going to plug in a 2, where would you start evaluating this? On the bottom. So g of x could be the entire bottom. Okay, there are other options. You could say it's just the 3x, but this is just kind of the simplest option. Okay, so think about what you do in a composition. We take something and we replace the x with it, right? So if I'm going backwards, if I take that something out, that means this was just an x to begin with. So function f would have been 4 over x. And you can always check it by just composing them and making sure you got the same answer. Okay, so your inside function is like the first thing you would do if you were evaluating it. And then if you take that out and replace it with x, you have your outside function.
Could we also do like g of x is 3x and f of x is 4 over x?
Yep. So there are multiple correct answers here. B. So I want f composed with g to equal a negative 2 times the absolute value of 7 minus 3x. Okay. So we have to figure out a possibility for f and g. We know there might be more than one. G is the inside. If I'm going to evaluate this, what am I going to do first? So multiply by 3. So you could make it just the 3x. You could do the 7 minus 3x. You could even make it the entire absolute value. All of those are options. I'm just going to do, let's say 7 minus 3x. So if I make that my g, f says you just replace that with an x. So my f would be negative 2 absolute value of x. Other options, you don't need more than one, but somebody had said you can make it a 3x. If your g was the 3x, then f would be negative 2 absolute value of 7 minus x. You just replace the 3x with the x. Final one, 3 functions. This is cosine squared. Sorry, I don't know why the square printed so weird. Okay. Inside is h of x. what would be the inside function here? X plus 9. So h is x plus 9. Okay, so I think about this. Cosine squared just means you're going to take cosine and square that answer. And if I'm working backwards, you would replace that x plus 9 with just an x. So g of x is the next thing. What's the next inside? Okay, if I'm working backwards, if I take that out, I replace it with an x. So that means f of x is just x squared. So that is our stopping point for today. On your homework packet, I don't have one I can look at. You are probably good to try up through problem 8. So really the second page, the back of that first one. But again, we'll finish this on Tuesday, so this packet will be due on Wednesday.